right, we're transitioning from energy to waves. They go hand in hand. Okay, as part of your benchmarks for nature of matter, which is your standard, okay, distinguish between longitudinal, transverse waves and their means of transferring energy. Okay. Hopefully you can remember the law of conservation of energy, what that law is. That's going to tie in with today. And the second benchmark, describe waves and vibration. Okay. I'm going to show you a video clip, a little demo, and while you're watching this demo, answer this question on your paper or in your head. What do you think is happening to cause the oobleck to dance? Somebody asked, what is oobleck? It's basically cornstarch and water. Okay. Hopefully you can see that. So here we go. What is happening? What do you think is happening as it's transforming? Well, just write what you think is happening. With a partner, discuss what you wrote down, what happened in the video. Go ahead. With a partner, talk about what you just happened. Did you answer the same question? What happened? Yep, they're from the... What do you know about waves?
They can kill you. They come in sets.
Come in sets and surf them? Okay, so waves. Okay. So again, what do you know about them?
Come in sets.
Okay. Caused by moon. Sure. What else? What else about waves you know about? You said come in sets? Come in sets. Okay. You really powerful? Good. Very powerful. At least one more, two more. What waves? Are waves only, because these kinds of waves you're talking about are what kind of waves? Okay, travel in air, okay. You can what? Cause depths. Cause here. Cause depths. What kind of wave is that? Talk about tsunami. You guys know how to spell that? Alright, good. There's my spell check right there. Thanks, Vincent. Thanks, Peaches. Alright, so we're pretty much talking about ocean waves from the sound of it. Okay, except for travel in air. Okay, ocean waves don't really sound in the air, but what kind of waves travels in air? Radio waves? Oh yeah, they were more talking about mechanical waves. That's getting more of the electromagnetic spectrum kind of waves, which we'll get into later on. Okay, what we're talking about mechanical waves, okay? Created when a source of energy is caused by vibration through a medium. What is a medium? Okay, real quick, about 15 seconds, talk to your partner. Talk to somebody. What is a medium? It talks about vibration through a medium. With a partner, real quick. What is a medium? Not talking about short, medium, tall, that kind of medium. We're talking about what type of medium. Mass? Oh, math. Okay, the medium, the middle point. Okay, all right. Not bad. And so that, you guys see the correlation. Kella, do you know what a median is? Okay, a median is something like a surface. Okay, it could be air, it could be a solid surface. Okay, so that's what a median is. Right. In your lab groups, okay, you're gonna have 3 groups. One of your group is gonna have a longitudinal wave. Another group's gonna have a transverse wave. Another group is gonna have a surface wave. Okay, and what you're gonna need to answer is this question. You're not going to get much help. You know me, I don't like to help you out when you do your labs. You're on your own. Okay? So, I'll have some questions on a piece of paper to help you out, guide you through a little bit, but you're on your own. Okay? Created a mini experiment that explains how your wave behaves. Okay? The 3 groups, you don't know which wave you have. You have to figure that out for yourself. Okay? You have to describe how you came up with the experiment to figure out how to work the wave. Okay? Some of you have experiences with different stuff, say like a jump rope, a slinky, ocean waves. So that's your only clue for the lab itself. Okay? I'll give you about 10 minutes or so to work out your little experiment. You can write on this paper to figure out what to do or how to do it. Okay? Then after 10 minutes, we're going to go over it. I'm going to ask you, how did you come up with it? Tell us what you did. And what is the wave and how does it behave? Okay? Any questions about that? Okay? So get in groups of 3s. So 1, 2, 3, 4, 5, 6, 7. So groups of 4. So you 4, you 4, you 4. Okay? Or pick your own. Okay? Questions? Once you have your 4 people together, go to the back. Okay? Oh, Kella, here. You guys take the slinky. Josh's group takes the jump rope. So how is that a wave? That's a good question. That's what he said. That's what you got to figure out. Get the 4 of you. Figure it out. Some questions so hard? Well, what do you have right now?
I think it's the one in the middle.
Yeah, I think so. Now, it could be that surface.
As you go along, talk amongst your groups. Yeah? You have to create that little experiment, observation, your hypothesis, and whatnot. Back.
Because the surface, so when you jump it, the wave spreads out. Yep.
What's that?
Told us straight up. Like the week.
Up and down. Okay, so remember you have to be drawing this, so I'll get you guys a paper.
See? But it's right on top. On top. I want to hit the bug. Okay, go again. What's the double thing for the lift up? Yeah. See? It's on the surface. It's on top.
To help you right, so I want to see what you've come up with.
Okay. So the harder we
the lower we move, the less weaker we move our hands, the smaller the weed.
We should get some markers. I don't know where they're at.
What am I gonna say?
No, for that. Make sure it's big enough for everyone to see. Well, what do you notice with that ball? Has the ball moved all the way across the tank?
No, just the water moved away.
Well, what if you like make a huge wave? What happens to that? Kevin. Here you go. It's right over there.
All we had to do was lift the bottle, right? Okay, so what you want me to write? On the top, will it be the surface waves? Just write the surface waves.
That's true. Figure out
So,
Well, one of the first things you should do is figure out which of the three waves that is. Yeah.
yeah, that's just the middle one. Because it's got the surface is downward. The first one is downward.
What do you think of longitude? What does that say? What does it mean?
Because the earth.
So when you okay, now you show me how you move the slinky again. So is that a transverse or is that a longitudinal wave?
No, it's a trans. For sure. No. Look at this. Oh, the wave is even.
Well, what does longitudinal mean? What is the main words in there? You say long.
it's long, okay? Long.
Long. Okay, so is that moving long ways or is it like a snake wise?
Snake line.
Snake wise. So do you think it's could be longitudinal, or do you think the other ones are different? Like, which ones?
Down is longitude because it's even longer than the snake. And it goes,
Okay. All right. So what do you think this
Probably
could this be a surface wave or a transverse wave?
transverse.
So what does transverse mean? What is that? When you're explaining to the other groups, how does that mean? Or what does that mean? Okay. You guys like that definition? I can live with that. Are you able? Can you explain to me what that thing is as it goes across?
The weight.
What? Because what are you doing when you get that wave?
No, not flicking it. Because how flicking it is.
Yeah, flocking is like that. It's fluff on.
It's a fluke.
So what do you pull me back? Can you see fluffy?
Flicking the slinky.
Yeah, you said it earlier.
Okay, step 2.
Fluff, like,
When you drop the ball, water creates
When you drop it, what are you trying to explain?
the wave.
I think when you drop the ball, the wave, it creates a wave that goes faster.
Or when you go and you push it down?
Yeah.
So are they the same thing or are they different? You drop the ball versus you push it.
It's different.
Why? It is?
Like keeping a line.
Make sure the tank's completely still if you want to show that.
By the line.
The one plug cannot move the whole thing.
Takes a while for the cell down. Okay, this is pretty good. Okay, you want to try and drop the ball. So what is it when the ball drops? The ball's creating something on the surface.
It's like pressure or something. When it goes down, then it comes back up and spreads.
I would say it's a force field.
What about you, Keone? What do you think? What's it creating when it hits the water? What's that?
Ripple?
Yeah, a ripple. So you think? So you're saying this ripple effect is different from when Vincent pushes him? Go ahead, push him.
It's the golf.
Now we do see.
So it's not. This kind of wave is different from the rippling.
Yeah, it's different because it's going back and forth.
But if this tank was longer, like say the whole length, the ocean or the length of the thing, would that be the same or different?
Yeah, it's still different because there's a size that
So you're gonna try to jump him again. Isn't the ripples hitting against the wall?
What?
For what?
Here, it's not here.
I'll get
so this
Josh.
is the same, it just looks different because
Got about a minute and a half left.